Okay, Wildcats. Today we're looking at Friday, February 9th, rational function inverses. All right, if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, rational function inverses on page 55. 4 ways to find the inverse, f inverse of x. Number 1, graph, reflect over the y equals x line. 2, table, switch x and y. 3, algebraic, switch x and y, and resolve for y. All right, the 4th way, composition of functions. When the result of f of g and g of f is x, then f of x and g of x are inverses. Domain and range will switch, and in rational functions, the asymptotes will switch. All right, would update your notes. All right, now your notes are updated. Let's look at the examples. All right, so example 1. All right, so we want to find this point and that point, okay? And to understand how to find those points is you look for the whole number, okay? Because there's only going to be one point on that curve that's going to usually be a whole number. It's not, and it won't always be a whole number there. But to find this, we look at -1 for x is a good x value to pick for this reason. 1 divided by -1 plus 2 equals 1. And then when x is 1, 1 divided by 1 plus 2 equals 3. Okay? Now, before we graph those points, we want to understand our asymptotes. So x equals 0, because that 1 divided by 0 would be undefined. And it shifted up 2, so it's y equals 2. Wow, that's a bell. All right, so x equals 0. All right, so then y equals 2. All right, so now we graph our points, -1, 1, and so that tells us our curve is here. And then 1, 3, so 1, 1, 2, 3, so our curve is here. All right, now for the inverse, it's really simple. You switch the asymptotes and the point. So x equals 2 and y equals, there's another bell, y equals 0. So x equals 2. And y equals 0. Okay, so now we switch our x and y points. So our new x's are 1 and 3, and our new y's are -1, 1. So now we graph those points. So then 1, -1, so we're here. So our curve is here. And then we graph 3, 1. So 1, 2, 3, 1. So our curve is here. All right, so let's take a look at example 2. Okay, so again, we want to find these 2 points. Okay, and to understand where those are, we look to try to make this a good point. And the best points to choose would be x is -3. So it's 1 divided by -3 plus 2 minus 3. So then that's -3 plus 2 is -1, minus 3 is -4. And let's use x as -1. And we're going to use that because it works out nicely. Okay? So that's a +1 minus 3 is a -2. Now before we graph those points, we want to identify the asymptotes. Okay? So x equals -2 because that makes that 1 divided by 0. And it shifted down to -3, so y equals -3. Okay, Now let's graph the asymptote. So x equals -2. And y equals -3. So now we graph our points. -3, -4. That's my phone. I should probably answer it, but I can't answer it at the moment because I'm making a video. All right. So now we go left 3, so left 1, 2, 3, down 1, 2, 3, 4. Wait a second. Let me redo that. 1, 2, 3, 1, 2, 3, 4. There we go. Okay, so there's our curve, and then left -1, -2, which is here. So there's this curve. All right, so for the inverse, we switch the asymptotes. So x equals -3 and y equals -2. Okay, so x equals -3, so -1, 2, 3. And y equals -2. All right, so now we switch the x and y points, so that's -4, -2, -3, -1. So we go left 4, so 1, 2, 3, 4, down 1, 2, 3. There's a curve here. Okay, and then we go -2, -1, so our curve is right here. All right, so now we're going to move on away from the graphing aspect, and then we're going to solve it algebraically. Okay, find the inverse algebraically. All right, so what you do is you switch the x and y, but before we do that, we're going to change f of x to y. Then switch x and y. So x equals 1 divided by y minus 2 plus 3. And now we're going to resolve for y. So we're going to subtract 3 from both sides. So it's x minus 3 equals 1 divided by y minus 2. Now at this point, I'm going to divide this by 1, so I have two fractions and an equal sign. And I know from 8th grade that we can cross multiply. Okay. So when we cross multiply, we get x minus 3 times y minus 2 equals 1 times 1 is 1. Now we're going to divide x minus 3 from both sides. That becomes 1. So you're left with y minus 2 equals 1 divided by x minus 3. We add 2 to both sides, so y equals 1 divided by x minus 3 plus 2. Hard to see if that's the actual solution, so let me darken it that way. There we go. All right, so now let's look at example 4. Our example 4, again, f of x to y, and then we switch x and y. So x equals, I'm going to put the negative in front of the 1, so -1 divided by 2y. Once again, I'm going to divide the left side by 1 and cross multiply. So I get 2yx equals -1. At this point, I'm going to divide both sides by 2x. That becomes 1, 1. So you have y equals -1 divided by 2x, which is fascinatingly cool. The inverse looks like it's itself. That's fascinating. All right. So now let's look at example 5. All right. So again, change f of x to y, and then switch x and y. So x equals 1 divided by y plus 4. We subtract 4 from both sides. So x minus 4 equals 1 divided by y. And then we're going to divide this by 1 and then cross multiply. So then you get y times x minus 4 equals 1. Divide both sides by x minus 4. This becomes 1. So you get y equals 1 divided by x minus 4. All right, last problem. All right, again, change f of x to y, and then switch x and y. So x equals, I'm going to put the negative in front of the 1, so -1 divided by 2, parentheses y plus 4. Divide this by 1, and then you cross multiply. So then you get 2y plus 4x equals -1. And then you're going to divide 2x by both sides, because that becomes 1, 1. So then you get y plus 4 equals -1 divided by 2x. Subtract 4 from both sides, so y equals -1 divided by 2x minus 4. And we are done. All right, so with this, you have two options. Option 1, you can wait till class and I go over some of these again with you. Option 2, you understand all examples and start working on the assignment. Either way, have a wonderful Wildcat day.